Believe it or not, the size and shape of human testicles, well, they can tell us a really fascinating story. A story about our evolutionary history, our mating strategies, and yeah, even our behavior as parents. So let's just dive right into this, because the science behind our family jewels is actually pretty wild. So here's what we're going to cover. We'll start with size, just to get some perspective. Then we'll get into this really cool idea of an evolutionary trade-off. After that, we'll see what it all means for us humans, look at the practical anatomy of it all, and finally take a peek at how our jewels are still evolving today. All right, first up, size in a nutshell. To really understand our own bodies, we can't just look at ourselves in a vacuum. We've got to compare ourselves to our closest relatives, our fellow primates. And when you do that, the difference is, well, it's pretty staggering. Relative to our body size, human testicles are a whopping 3 times bigger than a gorilla's. But here's the crazy part. They're only 1/5 the size of a chimpanzee's. We're right smack in the middle. So you gotta ask, why? Why such a huge difference? This isn't just random chance. The answer, it turns out, lies in 2 really powerful evolutionary forces that shape how we, and pretty much every other species, reproduce. And this leads us to the main event, the central idea here, the evolutionary trade-off. A really simple way to think about it is the show versus the go. Okay, so on one side, you have the show. Scientists call it pre-mating selection. These are all the flashy physical things. We can call them badges of status that help a male attract a mate or signal that he's the top dog. Think of a peacock's giant tail. Then, on the other side, you've got the go. This is post-mating selection. This is all about what happens after the mating is done. If a female mates with more than one male, it kicks off this intense sperm competition, basically a race to the egg. So when scientists started lining all this up and comparing different species, they found this absolutely amazing pattern. They saw that the more energy a species puts into the show, the flashier those badges of status get, the smaller the testicles. That's right, it's an inverse relationship. A primate with a huge, flashy nose, smaller balls. The one with the loudest, deepest roar? You guessed it, smaller balls. This pattern shows up again and again. And this is a perfect example of what an evolutionary trade-off is. See, every living thing has a limited energy budget, kind of like a bank account. You just can't be the best at everything. So any energy you spend growing, say a magnificent beard or a booming voice, is energy that you simply can't spend on growing bigger testes for that sperm competition. Okay, so what does this all mean for us? Let's bring this whole idea back home and see what this trade-off looks like in humans, from our beards right down to our babies. And this isn't just some abstract theory about other primates. A study on human guys found this exact trade-off playing out. They discovered that men with lower, more attractive voices, which you could argue is one of our pre-mating badges, also tended to have lower sperm counts. The show really does seem to come at the expense of the go. So here's the takeaway. Testicle size is basically a mirror reflecting a species' mating strategy. In gorillas, one dominant male gets all the action, so there's almost no sperm competition, and they have tiny testes. Chimps, on the other hand, they live in super promiscuous groups, which means sperm competition is fierce, and so their testes are enormous. And this might even tie into our behavior. One study pointed out that human fathers with larger testes actually reported spending less time on childcare. Which leads us to a pretty provocative question, even if it is just speculation for now. If testicle size is really a biological investment in trying to make more, instead of in parenting, could smaller testicles actually be linked to being a more committed partner and a more hands-on dad? It's a fascinating thought, right? All right, let's switch gears a bit. We've talked about the evolutionary why, so now let's get into the anatomical how. Why do they hang outside the body in the first place? And why are they so often, a little lopsided? It all comes down to function. The single biggest, most important factor is temperature. Sperm production is a delicate process, and it works best in a very specific temperature zone, about 2.5 to 3 degrees Celsius cooler than the rest of your body. If it gets any warmer, the whole factory just grinds to a halt. So to maintain that perfect temperature, the body has this brilliant 3-part cooling system. First, and most obviously, the testicles hang outside the body in the scrotum. Second, the skin there is really thin, and it's full of special blood vessels that act like a radiator, exchanging heat. And third, these little muscles called the cremasteric muscles act like a thermostat, pulling things up closer to the body for warmth when it's cold and letting them hang lower to cool off when it's hot. Okay, so that explains the hanging part. But it doesn't explain something that most guys have probably noticed. They don't usually hang perfectly even. So, what's the deal with the lopsidedness? Well, there's actually a perfect logic to it. Having them hang at different levels maximizes the surface area around them, which makes cooling way more efficient. It basically lets each testicle manage its own temperature without bothering the other one. And while it can vary, for most men, the right one is a little bigger while the left one tends to hang lower. It's not a bug, it's a feature. All right, for our last section, let's zoom all the way out and put all this into the grand timeline of evolution. Because where we are today anatomically, it's really just a single frame in a very, very long movie. If you look back, our ancient ancestors had all kinds of different setups, each one fine-tuned for their specific mating environment. Our current anatomy is the direct result of all those pressures from the past. But what's really wild is that because sexual selection is such a powerful and constant force, testicle size is actually likely to evolve faster than many other parts of our bodies. But hey, while the long-term evolutionary future is anyone's guess, the short-term personal future is, well, it's a biological certainty. As we get older, skin loses its elasticity and collagen, and yeah, that means things will inevitably hang a bit lower. It's just gravity and biology doing their thing, a fact of life. So we'll end on this final question. Our societies and our mating strategies are changing faster now than ever before in human history. So as we keep evolving, what kind of pressures is that going to put on our bodies? I mean, will our descendants look back at us and see our testicles as weirdly large or surprisingly small? Only time will tell.